first goal, I want to explain what the number E is and where it actually comes from. And then I also want to talk about what are called common logs and natural logs. The final goal for the day is going to be, we need to be able to use those common logs and natural logs, what we call them, to calculate all logs. That's our whole goal. So first is, what the heck is this number E? Well, we said the other day, exponential growth is the fastest way of any function can grow, right? We said, like x squared, y equals x squared. That grows. It grows really fast. And x to the third grows even faster. And, make this number whatever you want, it's going to grow really, really fast. But those types of functions are what we call polynomial growth. And they're kind of restricted. Exponential growth is just different. It's growing in a totally different way. Think about rabbits. Population, rabbits. If you got a dozen rabbits in your yard, are you going to wake up and have 1 million the next day? No, it's going to grow. It's going to grow, kind of fast, but not real fast. If one day you have 100,000 rabbits in your backyard, is there a good chance the next day you have about 1 million? Yeah, because populations grow that way, right? The more people, the more rabbits you have, the faster it can actually grow. Money works the same way, okay? I want you to think about banks. The more money I have in the bank, the more interest, right? Like that's actually how my plan is to retire. My goal is I want to get $2 million in the bank. The day I get $2 million in the bank, adios. I ain't coming back in here. I love you guys all and I want to teach, but I can make enough money to survive. I'd rather just go play golf or do whatever I want to do. But how what happens when you put money in the bank? It gets interest, right? But how does that interest work? Does anybody know the interest formula? Huh? You're close. Look on page. I'll let you read it off. Look on page 359. It's right there in the middle of the page. 359. So it's A equals. I'll let him read it to me.
P times the value of 1 plus R over N to the N T.
To the what? NT power, right? So that's your compound interest formula. Not something you need to memorize right now, just this is how this works. P is your principal. It's how much money you have in the bank, okay? R is your interest rate. Anybody know what N is? N is the number of times that's going to get compounded, okay? Now, basically, if I put $100 in there, is every single $1 going to basically act the same? It's going to grow at the same amount. So let's just do this. Let's assume that's a 1. Let's assume I only have $1 in the bank, okay? And let's assume we find a really generous bank, and they're going to give us 100% interest. Now, it seems crazy, but at the same time, if you think about like populations in rabbits, it's not really that far-fetched because can rabbits just double in size? Like the number of rabbits, can they just double in size? Yeah, they can do that faster than 1 year, can't they? So it's not really, it's kind of a little far-fetched when we talk money, but there's other applications of this where the 100% interest growth, that's not really that far-fetched, okay? So we'll just say this rate is 1 as well for simple calculation, okay? Now, we're also going to say, let's just do this for 1 year, okay? We're going to see what happens to this money $1, 100% interest, 1 year. Now, N is how often is this compounded? Do I get once a year? So if I do it for once a year, okay, that means I get the 100% interest. They wait till December 31st, and they give me all my interest for the year on that day, right? Make sense? So what is that calculation? After 1 year, or if I calculate it one time, 1 plus 1 is 2. To the 1 power is going to be 2. So if that $1 makes sense, doubled in size, I get $2. Simple? But let's say I now calculate it twice a year, meaning I don't get the 100% interest twice. Instead of getting the 100% interest twice, I get 50% interest twice, right? Now, is this going to be more or less than getting the 100% once? Is it better to get 50% twice or 100% once? What do you think, Liam? It's not the same. It's really not the same. Why is it better to get 50% twice than 100% once?
Because it's going to take the 50% of.
So I got my pot, right? Okay, what happens?
It's going to
Get a little bit bigger, right?
be a little bit bigger.
Okay.
And it's going to grow 50% more from the bigger one.
Right. The second time I get the 50%, don't I get more because there was more in the pot, right? So instead of just getting it one time, my pot started, instead of growing to here one time, it grew a little bit. But now because it's a little bit bigger, the second time I get the 50%, I get more, right? Because there's more in the bank. The more money I have in the bank, the more interest I get, right? So what's this going to be? 1 plus a half. All right, if you don't have a calculator out, get a calculator out. We're going to do this. You guys are going to be my calculators. So 1 plus a half would be 1.5, right? What is 1.5 to the second power? So you're doing 1 plus a half, and then raising that to the second power. What is that? 2 point what? 2.25? 1.5 to the second power. Yes? Now, you also are going to have to I don't want you to round decimals here. So, what would be better than getting it twice a year? Let's do it 4 times a year. So, type in your calculator, 1 plus a quarter would be 1.25, right? To the 4th power. So if I do it 4 times a year, 2 point what? 44 or whatever. Okay, so it's getting better, right? So if I only do it once a year, I'd only get $2. If I do it twice a year, I get 2 1/4. If I get $2, I get 2.44. It's getting more, right? Well, the heck with this. What's better than 4? Great, let's do it 100 times. So type in your calculator this way. Do 1 divided by 100. Get that answer. Get that little decimal. Plus 1. Raise that answer to the 100th power. What is it? 2.70. Okay, that's even better. What's better than 100? Let's do even better than that. How many seconds are there in a year? Let's have the bank give us interest every single second. How many seconds are there in a year? It's not that hard to figure out. 24 hours a day. So you're the one with a calculator in your hands.
Hang on, I got the number.
So you got 365 days a year.
1,536.
You've got 24 hours in a day, 60 and 60, right? Let's use that number. So we're going to do 1 divided by that. Okay? We're going to add 1 to that. So it's going to be 1.0000 whatever. We're going to raise that to that 3 billion, somewhere in there. And we get 2.7, but wait a minute. That should have been a lot higher, shouldn't it? Because like we made a big jump just going from 1 to 2. We made a big jump going from 2 to 4. We made a big jump from 4 to 100. But from 100 to 3, are we at billion? 31 million? We only added another cent? Doesn't that seem a little off? So what's happening here, if we plot these on a graph, if we plot those numbers on a graph, what's happening here is this. After 1, we are at 2. 2, we're at 2 1/4. We're a little higher. 4, we're here. You know, that $1, and what's going to happen is there's this upper asymptote. There's this asymptote where this curve is going to get closer and closer and closer and closer and closer to this weird number. I can do this even more, to take bigger and bigger and bigger numbers, and it doesn't matter how big of a number I put in here. All it's going to do is keep getting closer and closer and closer to this weird number E. And that weird number E is what ends up happening. Okay? This number is what we call the natural number. It shows up as soon as you start dealing with anything with exponential growth of different types. This E number keeps popping its rear head. Just like anytime you deal with circles, what magical number pops up all the time? Pi. Shows up in circumference, shows up in area. Heck, if I throw this pen up in the air, the probability that it lands on one of those lines on the floor, pi, will be in that answer. Like because it's kind of circular. That's got a circle, chanceability. Like, it's going to show up in that answer somewhere. E is kind of the same thing, but with exponential functions. That's all this number is. So that's actually, when it comes to money, you can say, calculate it 1,000,000 times, 1,000,000,000 times, 1,000,000,000,000 times. It doesn't really matter. It's just going to get closer and closer to that 2.71. Let's just use that 2.71, and we'll just call it continual growth. Okay? And that's where that number comes in. Okay? So that's what E is. Now, in logarithms, we have 2 special logarithms. Okay? We have one that looks like this. There's a button on your calculator, okay, that you can use to find the log of 72. Okay? There's a button on your calculator for that, right? There is a base there. We just don't write it. There's a 10 there. This is the same thing as log base 10. This is what we know it or call the common log. Now, what's the word common mean? What's the word common mean? Normal. Like we use it a lot, right? Anybody know why 10 is the common log? Anybody know what number system we use? We use a base 10 number system. Okay? Anybody know why we use a base 10 number system? It's the same reason why if we ever meet the aliens, they're not going to use a base 10 number system. Anybody know why we use a base 10 number system? We have 10 fingers. That is absolutely the reason why we use a base 10 number system. What a base 10 number system means is there are 10 symbols. We have 1, 2, well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 symbols that we use to represent a number. Once you get through those symbols, what do we start to do? We start back over, but we count there. And we count 11 and 12 and 13. And we go all the way to 19, and then we go to 20, right? And then we get to 99, and we use all the symbols for two digits. So what do? We add a third digit, and we start over, right? There's another very common one that we use. Base 2. How many symbols of numbers would we have? 2. We have a 0 and a 1. Those are the only 2 symbols you can use to count. Great. It goes 1. Crap, I'm out of symbols. What do? I start over and I add a second digit. Great, that's 2. That's 3. Crap, I'm out of symbols. What do? I start over. I add another symbol. 1, 2, 3, 4. Owen, will you stand up for a second? Will you walk to the back of the room? Right next to the calendar, right above where it says count today, there's a little, yep, read that to the class, please.
There are 10 types of people in the world, those who understand binary numbers and those who don't.
That's not what that says. Can you read that again, please? Read it again, please. Just read it one more time, please. Loud and proud so everybody can hear it.
There are 10 types of people in the world, those who understand binary numbers and those who don't.
Would you like to help him?
I feel like I'm one of the people that don't.
Okay, would you like to read that for the class?
There are 2 types of people.
There are 2 types of people in the world, those who understand binary numbers and those who don't. Because that is the number 2 in a binary number. Okay? Now, we use a 10-digit number system. Okay? There's a 10, we use a 10 or base 10 number system because we have 10 fingers. That also means if we ever see the aliens and they show up with only 8 fingers or something, they're probably going to use a base 8 number system. It's only stupid because you're not used to it. If you had 12 fingers on your hand, we'd probably have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and great. We just have different symbols. We'd have more symbols.
See, but the rest is like
Zero's up there. You gotta count 0. Yeah, that's a symbol. Okay? And then this, you count to here, right? And then you'd start back over at, that would be like 13. But it's still a symbol, right? In a base 10 number system, how many symbols do you have? You got to count that one. That's the 10th symbol, right? Make sense? But a base 8 number system would only go to 8, right? There's no such number. Actually, it'd only go to 7. There's no such number as a double circle that looks like an 8 that we know is an 8, right? So I got to keep counting. So once you get through that, what's the next number you'd write down? 10. It looks like. No, you don't actually need to know all that base number system. I'm never going to test you on that. It's just kind of a fun side note. But that is why we call it a base 10 number system. Or that's why we call log base 10 the common log. So when you see log of 72, what it's really asking you is 10 to what power is equal to 72? Well, that's going to be about 1.6, something like that, 1.7. Because wouldn't 2 be 100? Like 10 to the second would be 100. So it can't be all the way to 2. It's got to be something like that. What is log of 100? Just press the log button. 1 hundo. Oops, that's that one. I wanted log of 72. Log of 72, 1.85. I was in the ballpark. Make sense? There's another button on your calculator. Oh, that's right. We're no bells today. See you guys tomorrow. We'll talk finish tomorrow.